Oh, that's nice. Hello YouTube and welcome back. And these are quite expensive Christmas lights apparently. These carriage lights. I've upgraded them to LED for somebody, but they've returned them because they don't work. So turn the power on. See, it draws 1 and a bit watts. No lighty, which is interesting. So there's the plug. It's got my little circuit board in it. Let's take it apart and see what's gone wrong. Oh good, I filled it full of glue, so it'll make it really easy for me to repair. That was a stupid idea, wasn't it? Well, probably seemed a good idea at the time. So that's my little circuit board. It's a little dropper capacitor. And then basically a little rectifier circuit, that's all it is. So your capacitive dropper, limit the current to the string of LEDs, because the string of LEDs can be about, I don't know, a couple of 100 volts. 3 volts per LED. How many LEDs are there? I'll count them in a minute. I'll give you a rough idea, because we need to measure that to see. So the first thing we've got to do is just measure across the supply, make sure we're getting the voltage we assume we're going to be getting, and then go from there. Luckily, I was sensible enough to use hot glue. So just a bit of heat and it's all peeled off. So measure the output across these terminals. Count the LEDs, there are 20. 20 times 3 volts per LED. Should be having about 60 volts across these 2 points here. So we'll get the meter and we'll give that a measure. Got to plug it in and balance it all precariously. Safety, it is on an ungrounded inverter. So it shouldn't kill me quickly, it'll kill me slowly. So that's a nice sign. On the input, so the main side, I'm getting 230 volts, which is correct. And then do this very slowly. Oh, of course it's DC. Don't put your finger on the wrong bit. Death shall happen. And I'm getting 24-ish volts on the output. This is not good, because we were expecting 60. So, yeah, how much ripple is there? Just out of interest. So ripple, we're going to go back to AC. And measure the output. Okay. 8 volts for ripple. That's quite a lot. Okay, so what I'm going to do, I'm going to unsolder. Let's turn that off. Unsolder the output so that there's no load. So we isolate the LEDs. We should be getting around about 400 volts out of that supply. If we're not, there's a problem. I've disconnected that wire, so there's no load. So it's just measuring the output of the supply with no load. It's 27 volts. No, 20-ish volts all over the place. If I go to AC, 9 volts of ripple. I wonder, has the output cap gone shortage or something, and that's causing it to drop the supply? Because there's not much on here. So I've removed the cap, and that hasn't fixed it. Well, it wouldn't fix it, but I mean, it's not the cap, is what I'm saying. So I've measured across the cap, and it measures fine. I've also measured the output here, and it's still 0. So it's like, well, there's no power getting to it. So I've had a quick buzz around the board. There's nothing to it anyway. So I've checked all the components. And this resistor here, which is an inrush limiting resistor. So you've got mains comes in through this fuse, through this inrush limiting resistor, then to the cap, just to stop inrush currents. And if I measure that, oh, I'm going to do this using my single hand claw technique. It's open circuit. The resistor's gone open circuit. Now that's rather interesting. I've got this is the second one I've had back that's failed. Is there an issue with that resistor? Is it a voltage issue? Is it a current issue? Well, let's change it and see if it works. I found the bag of resistors. RS part number for those playing along at home. So I'm going to change that resistor. I shall do that now. The resistor has been changed. Shall we see if it turns on? Hey, we have light. Look at that. So they're all lit up now. Hey, that's good. So, why did that blow up? Off camera, I've measured the voltage drop across that resistor, and it's a 470 ohm. So if you look, it's 471, which is a 10. So it's 470 ohm resistor. It's got a 30 millivolt drop, which gives us a power of 1.9 microwatts, which is nothing. And if we go to the data sheet for that device. Well, it's not a data sheet, that's the actual thing there. 470 ohm, and it's a quarter watt, so it's well within its rating. It's only got a 30 volt drop, and it's been discontinued, which is nice to know. So why it blew up, I don't know, because it's within its rating, and it's not anywhere it's getting hot, because this circuit doesn't really get hot. So I'm not sure. It's a confusing one. I'll have a think. And if you can think why it would blow up, let me know. Unless it's just me badly soldering them. So I'll leave you with the fact it's working at the moment. And I shall see you later. Bye for now.